These are the practice problems for lessons 5 and 6. Classify each function as odd, even, or neither. So, an odd function is symmetrical about the origin. An even function is symmetrical about the y-axis. And neither is neither symmetry. So, as we look at this first one, you can see that if you folded this graph in half along the y-axis, it would be symmetrical. Therefore, this is an even function. For number 2, if you took the right half of this graph and you swung it around onto the left half, it would be symmetrical. So the symmetry is about the origin. And therefore, this is an odd function. Number 3, if I fold this in half along the y-axis, they don't line up. So it's not symmetrical about the y-axis. And we can see that this is not symmetrical about the origin either, because the graph has been shifted up by 1. So this would be an example of neither. And number 4, if I tried to fold this in half along the y-axis, you can see that these would not line up. This top half would be up here and the bottom half is still down here. So it's not even. But if I took the right side of this graph and swung it around onto the left half, then it would be symmetrical about the origin. So this would be an odd function. So remember that if it is symmetrical about the origin, then it's odd. If it is symmetrical over the y-axis, then it is even. Here is the graph of y equals x minus 2. Number 1, is there a vertical translation of the graph that represents an even function? Explain your reasoning. Remember that an even function means it is symmetrical about the y-axis. So if I fold the right half over onto the left, you see that these do not match up. This would go off this way instead of lining up. So for number 1, no, it's not symmetrical across the y-axis. No matter how much we shift it up or down or left or right, we would end up with a negative slope across the top and a positive slope across the bottom. Number 2, is there a vertical translation of the graph that represents an odd function? Explain your reasoning. In this case, if I shift up 2, then I have a line that goes through the origin. Now, if I took this side, the right side of the graph, and I rotated that around the origin, these would line up. You can think about folding it diagonally down and lining up. You can think of it as folding the right half over onto the left and then folding it down across the x-axis. Or you can think about rotating it 180 degrees. However you want to think about it, yes, shifting up 2 units represents an odd function. So again, remember, an even function is symmetrical about the y-axis. An odd function is symmetrical about the origin. The table shows the values of an even function f for some inputs. So what you need to know is that an even function we said was symmetrical about the y-axis. That means f of x will have the same value as f of negative x because we are just mirroring across that y-axis. So they want us to complete the table. Here, we don't know what f of negative 3 equals, but we do know that f of 3 equals 0. For this to be an even function, f of 3 needs to be the same as f of negative 3, so that means this is 0. Next, we have f of negative 1. That means it needs to match f of 1, which is negative 1. Now, if x is 2, then that needs to be the same as when x is negative 2. So if f of negative 2 is 8, then f of 2 is also 8. And finally, we need the value of f of 4. Well, f of negative 4 is 2. That means f of positive 4 also needs to be 2. The function f is odd. Which statements must be true? Select all that apply. So A and B are testing the first piece of knowledge we need to have. If this is an odd function, then f of x equals f write this differently. Equals negative f of x. So for a, f of 5 equals 2. The negative of that should be f of negative 5 equals negative 2. That's not what we get. Here, if f of 5 equals 3, then f of negative 5 equals negative 3 is the correct way to explain an odd function. They're going to have opposite values when we change to the opposite x. Next, we're talking about the reflections. So remember, an odd function is symmetrical about the origin. So, choice C says reflection over the y-axis takes the graph of f to itself. That's the definition of an even function, not an odd function. So it's not C. D says reflecting f across both axes take the graph of f to itself. This is the correct explanation. If I take a graph and I reflect it over the y-axis and then over the x-axis, I will get the same graph back. It's symmetrical about the origin. So D is a correct way of explaining this. And finally, f of 0 equals 0. Remember, we said this is symmetrical about the origin. That means our graph needs to go through the origin, and therefore f of 0 is going to equal 0. So this is what it means for a function to be odd. Here is a graph of a function f for x values between 0 and 5, both included. Number 1, the function g is even and takes the same values of f for 0 to 5, both included. Sketch a graph of g. Remember, even functions symmetrical about y-axis. So if I fold this over the y-axis, then it's going to start right about here, and it's going to curve down until it meets up. It's symmetrical about the y-axis. Number 2, the function h is odd and takes the same values as f for x's between 0 and 5, both included. Sketch a graph of h. Well, odd functions symmetrical about origin. So if we take this and we go over the y-axis and then down over the x-axis, now our values are going to start here and curve up to join at the origin. So my blue line is H, my red line is G, and now we have the graph of a function that's even and the graph of a function that's odd. Classify each function as odd, even, or neither. To do this, we'll look at number 1. If I have x in here, I get 3x to the 4th plus 3. If I substitute negative x in here, then I have 3 times negative x to the 4th plus 3. Since I have an even power here, this is going to become positive x. So that becomes 3x to the 4th plus 3. Since they're the same, this is even. On the next one, if I substitute negative x in here, negative x to the 3rd minus 4 to the negative x, a negative to the odd number power is going to be negative x to the 3rd. And a negative times a negative is going to be a positive 4x. So I have the opposite. Instead of x cubed, I have negative x cubed. And instead of minus 4x, I have plus 4x. Since they are exact opposites, number 2 is odd. Number 3. If I substitute negative x in here, I get 1 over negative x squared plus 1. A negative number squared is going to be positive, so I will get 1 over x squared plus 1, which is exactly what I started with. Since they're the same, they are even. And number 4, if we substitute negative x in here, we have negative x squared plus negative x minus 3. A negative squared becomes a positive, and then a positive or add a negative becomes negative x minus 3. The first part, x squared, is the same, but the second part, instead of being plus x, is now minus x. One part of it is the same, one part of it is opposite. Therefore, this is neither. It's not exactly the same, and it's not exactly opposite, so it's not even or odd. The linear function f is given by f of x equals mx plus b. If f is even, what can you conclude about m and b? If this is even, f of x equals f of negative x. So if I plug negative x in there, then mx plus b would have to equal m times negative x plus b, and that can only happen if x equals 0. And if x equals 0, then mx goes away, and this just equals b. So this is a horizontal line. It has no slope, and it has one y value wherever the y-axis is, or wherever the y-intercept is. It keeps that y value all the way across in both directions. Here is a graph of the function f given by f of x equals x cubed. What happens if you reflect the graph across the x-axis and then across the y-axis? So what they're saying is, first we would take this original graph and we would flip it upside down across the x-axis, which would give us a graph that looked like this. But then if we flipped it across the y-axis or around the y-axis, we would end up right back where we started with a graph in the exact same spot. So for number 1, the graph comes back to itself. Number 2, is f even, odd, or neither? F is odd because it's symmetrical around the origin. If you reflect this across the x-axis and then across the y, you end up with the exact same graph again. If I rotated this graph 180 degrees, I would get the exact same graph again. That makes it an odd function. Here is the graph of f. Number 1, graph the function g given by g of x equals negative f of x. So in this one, the negative is outside the parentheses, so we're making the y value negative. So we're still going to have a point at the origin. This positive 1 becomes a negative 1. This positive 2 becomes a negative 2. And this positive 3 becomes a negative 3. And then we can draw the line connecting them, and we have the graph of g of x. Next, they want us to graph the function h given by h of x equals f of negative x. So now it's the x that's going to become negative. So again, we're at the origin. This positive 1 becomes negative 1. This positive 4 becomes negative 4. And this positive 9 becomes negative 9. And then we draw the line that connects them. And the blue line is h of x. Write an expression for two of the graphs in terms of f of x. So we have f of x, and we can pick any two out of the four dashed graphs. So first off, I'm going to look at A. And if I go from this peak over to this peak, I see that I shift left 1, 2, 3, 4, 5, 6 spots. So when I write that, A of x equals f of x plus 6 because I shifted left 6 spots. Next, I'm going to look down at graph D to go from the point at the peak of f of x down to the peak of d of x. I can see that I'm shifting down, and I'm going down 5. So d of x would be f of x minus 5. Since I shifted down 5, I put minus 5 outside the parentheses. Here are the graphs of y equals f of x and y equals f of x minus 1 for a function f. Which graph corresponds to each equation? Explain how you know. Well, f of x minus 1 means this was shifted right 1 unit. And if we look, that means the left graph must be f of x because the graph on the right has been shifted 1, so it must be f of x minus 1. This is the last question in our practice problems for lessons 5 and 6. The graph models Priya's heart rate before, during, and after a run. Number 1. What was Priya's approximate heart rate before and after the run? To find that, we're going to look at the beginning point and the ending point. And we can see that the value is just above 75. So her heart rate was about 80 beats per minute. Number 2. About how high did Priya's heart rate get during the run? For that, we want to go to this top line segment up here. And we can see that that is about 150 beats per minute. And number 3, sketch what the graph would look like if Priya went for the run 3 hours later. We simply take each point and we move it 3 hours later. So a beginning point here, then here, then we go up to 150. We stay there for a little bit, and then we come back down and we finish. So all we do is take the graph and shift it 3 full units to the right. If you have any questions about any of these practice problems, please use class time to get clarification before we move on to lesson 7.